Hey there, everybody. Welcome to the next lecture for the Linear Algebra Engineering Mathematics. So, in the very first lecture, हमने देखा था कि what is engineering mathematics and why do we study engineering mathematics. All right, where we have seen three different examples of our topics, which are linear algebra, calculus, and probability and statistics. All right, so here we are starting with linear algebra, और उसमें भी the first topic, which is matrices, that is what we are going to cover today, right? So before starting, let's look at why linear algebra. Okay, in the very first lecture, in the previous lecture, we have seen why do we study linear algebra, and we got to know that there are so many different applications, real world applications, where the linear algebra is already working behind the scenes, right? So here's a glimpse of it. Okay, for the full explanation, you can always go and you watch the previous lecture where we have looked at why do we actually study linear algebra and why is it helpful with the real world example. So even if you talk about AI, machine learning, deep learning, today when we are talking about large language models, linear algebra is working there as well. Linear algebra is working in artificial intelligence, machine learning, deep learning. Okay, in the previous lecture we have seen Netflix recommendation system, how the linear algebra is working in the Netflix recommendation system, how the Spotify application that you use to listen to the songs, how does it make your daily mix, and how does it know that you want to listen to what kind of songs. Okay, and it creates daily mixes automatically for you. Okay, then Instagram and Snapchat filters, how does Instagram and Snapchat filters are applied on your images. Okay, there also the linear algebra is working behind the scenes. Then computer vision and graphics, these things could not work without the linear algebra. Okay, even if we talk about social networks, the algorithms that are working behind the scenes, they are using linear algebra. All right, image and audio compressions and almost everything. These are just few of the examples, but almost everything nowadays, if you talk about the computer graphics and where we are talking about 3D spaces. Okay, so everything is working with the help of linear algebra. Okay, and not just the computer science, but in any other branch also linear algebra is working. Okay, if you talk about electronics, electricals, everywhere. All right, so I would highly recommend you to go to our previous lecture and see that particular video first, and then you'll understand completely why do we need to learn or study linear algebra. All right, so moving on to the next slide. Here is the linear algebra syllabus for our engineering mathematics subject. All right, and where we are going to have a look at matrices, we are going to study that. Now here you can see vectors. ये बहुत ही important topic है because vectors are basic building blocks of linear algebra. Okay, and how the computer science student views the vector. So for a CS student, a vector is just an ordered list of numbers. So here you can see there are two numbers, 1 and 4. So there are individual components and together they form an ordered list of numbers. Okay, and this ordered list of number itself is called vector. So if you see, there are two components, 1 and 4. Now here if you can see, there are three components, 2, 5 and 4. Here as you can see, four components are there, 2, 5, 4 and 1. So all these components together form a vector. So this is a vector. Now what kind of vector is this? So if there are two components in a vector, we can call it as a 2D vector. Okay, so this is a 2D vector. Then if there are three components in a vector, okay, vector is just the ordered list of numbers. So if there are three components in there, we will call it as a 3D vector, three-dimensional vector. Now here, how many components are there? 1, 2, 3 and 4. So what we will be calling it, four-dimensional vector. So it's a 4D vector. Okay, so these vectors are just ordered list of numbers and nothing else. And this is how the computer science student look at the vectors. All right, so whenever we are talking about vectors, I want you to think of an arrow which is pointing in some direction. So there is a direction and this arrow is pointing in that direction, and this arrow is of a specific length. All right, and we call it as a vector. And this is how the physics student view the vectors. All right, we have seen previously how the computer science student looks at the vector. He will just be looking at the vector as the ordered list of numbers. Okay, so this is an ordered list of number, it's a vector. But this is a computer science student view. But here the physics student looks at the vectors in this particular format. It's an arrow which is pointing towards a direction and that has a specific length. All right, now just place this arrow. You have to place this arrow in a coordinate system just like this. And that coordinate system could be xy plane, x-axis, y-axis, and just imagine that arrow is there. So this arrow is a vector. Okay, we know that the physics students view the vector as an arrow on a coordinate system which is pointing towards a direction, and this arrow is of a specific length. Okay, now this particular plane or space is known as 2D plane or 2D space. Okay, and wherever we have 2D vectors, so this vector has two components, so this is a 2D vector. Again, this vector has two components, but there are two different vectors. Vector 1 is here. Okay, so I will write v1 as a vector 1, and this is a vector 2, v2. All right, so there are two different vectors combined together. They form something called matrix. Okay, so this is a matrix, and this two-dimensional matrix can also be imagined in this coordinate system in the 2D plane, or we can also call it as a 2D space. Now tell me what will happen if there are three different components in one vector. Okay, what will happen if we have three components, 1, 4 and 2, for example, and this particular vector having three components, can this be seen in this kind of coordinate system in 2D plane, in 2D space? No. For three-dimensional vectors, we need a 3D plane. All right. So here is the 3D plane. If you can see, we have now three-dimensional vector. Okay. And why three-dimensional vector? Because this has three components, 2, 5 and 4. Okay, three components, so three-dimensional vector. And here we have 3D plane or 3D space to represent this particular vector. Now there are three different vectors over here, I hat, j hat and k hat. And what if we try to combine three 3D vectors? It will form a 3D matrix. So this matrix is formed which has three different vectors. One vector is here, one 3D vector, the second 3D vector, and the third 3D vector. So there are three different 3D vectors. And all of these are combined together to form a matrix. And this is a 3D matrix. So whenever we have 3D matrices or 3D vectors, they can be represented on the 3D plane or the 3D space. All right. And this entire thing is called a vector space. So linear algebra is the study of these vector spaces. We have seen what the vectors are. We have seen the spaces, 2D space, 3D space, right? So linear algebra is the study of these vector spaces. And what are these vector spaces? These are mathematical zones where these vectors live and move. Okay, जहाँ पे ये vectors move करते हैं, right? So that is a vector space. Now see, here are the matrices. Okay, this is the first topic that we are going to look at in our syllabus of linear algebra. And now that you already know what the vectors are, okay, here you can see we have combined multiple vectors to form a matrix. Okay, so here is a vector 2D vector 1 and 4. Here is another 2D vector 2 and 5. And when we combined both the 2D vectors together, we have got a matrix, and this matrix is named as A. So matrix is what? Numbers arranged in rows and columns in square brackets. Square brackets के अंदर rows and columns में numbers को arrange कर दिया. That is a matrix and nothing else. And now we have this B matrix where there are three different 2D vectors. If you can see it, first vector, okay, this has two components. I will call it vector 1. This has two components, 1 and 4. Now this is vector 2. Okay, this has two components, 2 and 5. This is vector 3. Again, it has two components because this is a 2D vector. So 3 and 6, two components are there. Now we combined all these three different vectors, v1, v2 and v3. Okay, and together these vectors form a matrix. And matrix is what? Nothing but numbers arranged in rows and columns in square brackets. So now you completely know the idea how the matrices looks like and how the vectors looks like. Okay, and when we are stacking the vectors horizontally, so we have stacked the vectors horizontally, v1, v2 and v3. We can also stack these vectors horizontally. Okay, just like 1, 2, 3, 4, 5 and 6. So this is a vector 1. Okay, this is a vector 2, 2 and 5. This is a vector 3, 3 and 6. So these three vectors have been stacked vertically. So even if we are horizontally stacking the vectors, even if we are vertically stacking the vectors, in both the cases, these are forming a matrix. Okay, a matrix of numbers arranged in rows and columns. So now you completely know the idea of matrices. Then here is another matrix called C. All right, and C has different elements. All these are different elements inside it, but there are three different 3D vectors. If you can see, first 3D vector, I will call it v1. Second 3D vector contains three different components, 1, 2, 2, which is V2, and third vector, which is V3, having different components 5, 1, and 3. So 3 vectors horizontally stacked together, okay, which is forming a matrix called C. Now there is a concept which is order of a matrix, which is nothing but number of rows into number of columns. So that's how we represent the order of a matrix. So let's say, let me clear all this. Now here if you can see, matrix A has the order 2 by 2, 2 into 2, right? Why? Because this matrix A has two different rows, and the rows are called I1. This is the I1 row. This is the I2 row. Okay. And there are two different columns as well. So J1 column is here. Okay. And J2 column is there. And because we have two rows and two columns, so rows into column we write, number of rows into number of columns we write. So 2 by 2 matrix is there. Now here, how many rows are there? How many columns are there? So I1 is there, I2 is there. And how many columns? J1, J2, and J3. Three different columns are there. So two rows are there and three columns are there. This is the order of this matrix B. Now what is the order of matrix C? 3 by 3, because three rows, I1, I2, I3, and three columns, J1, J2, and J3. So that's why rows into columns, rows are 3, columns are 3. So this is the order of the matrix C and nothing else. This is just the very basic concept about matrices. Okay, this is how the matrices looks like. Okay, and order of a matrix is rows into column. And here if you can see, the matrix called A has an element A at the location I and J. This I and J represents where that particular element A is located. Okay, and there's an order of the matrix. So I is the row and J is the column. Now if I ask you, where is this particular element number 4 is located inside the matrix A? So you can quickly see it. I1 row is here, I2 row is here. Okay, and this is the J1 column and this is the J2 column. All right. तो 4 कहाँ पे लोकेटेड है? I2 पे और J1 पे. तो 4 की लोकेशन होगी 2 and 1. Okay, so A of 2 and 1. A represents any element in the matrix. So that's what is written over here if you can see. Okay, A is 2, 1. Now what is the location of this element called 5 inside the matrix A? It is A22. As you can see, the row is 2, so A2, and the column is also 2, so again 2. So this is A22. So at the position A22, we have a component called 5. So this is the notation that you have to keep in mind. Okay. So these are matrices and nothing else. Now if we talk about this C matrix, what is the location of this particular component? So we can see that here we have I2, which is the row 2. Okay. And we have the column 2, which is J2. So row is also 2, column is also 2, and element is A. A could be any element. So at the location A22, we have this component called 2. Okay, what is the position of this component? 1, it is B23 because the row is 2. Okay, this 2 row and the column is J3. Okay, so 3, B23. At the position B23, we have a component called 1. All right, so these are the matrices. These are the order of a matrices, and these are rows and columns. And now you know what are the matrices, what are vectors. Okay, please keep in mind the basic building block of entire linear algebra is vectors. Okay, and finally, now is the time to show you the syllabus of matrices. So we have order of a matrix that you already know. What are matrices? You already know. What are vectors? You already know. Then next upcoming topics are matrix operations, transpose of a matrix, trace of a matrix. Okay, and then different types of matrices are there. We will see those matrices one by one, and also we will keep on visualizing these matrices and how the transformation operations work in the matrices. So this is what we are going to have a look at. Now here we have this 2D space, the coordinate system XY plane, and we have a 2D box over here, square, which has I hat and J hat. Okay, here there are some transformations that could be done on this particular matrix. If there is a matrix, it will be having two different vectors. So here if you can see, there is a matrix, okay, which has two different 2D vectors. So this is a vector 1 and this is the vector 2. Okay, I hat and J hat, two different vectors are there. Now if I remove these grids and coordinates, everything and vectors, you can see this is an empty space. Okay, but if we place the coordinate grid system, then we have the 2D space over here. Okay, two-dimensional space. Now here if you can see the demo transformations of any matrices. So if I click on rotate, see the entire 2D plane is rotating. Okay, because we have performed a matrix operation. When we perform an operation on a matrix, it transforms the view of that particular plane. Now if you can see, if I click on scale, then the vector has been scaled. If I click on the shear, then you can see it has slightly tilted towards the right. Okay, so this is the shear transformation on a vector. The original vector was like this, but if we click on reflect, this entire thing will be shifted and will be reflected as if a mirror is placed in front of it. Okay, so if I click on reflect, see, it has been reflected in the very opposite direction. If I click on project, then see, it has been projected. If I squeeze the entire thing, see how the entire plane has been squeezed. So these are transformations, and how the transformations are happening because of the matrix operations, the entire plane is changing its form, and that is what the transformation is. So vectors are transformed. Okay, so whenever we are talking about matrix operations, you always have to keep in mind that the entire plane is changing. Now here, this was just the 2D plane. Okay, but what if we talk about 3D projection? So here's the 3D plane where we have 3 different dimensions. यहाँ पे हमारे पास 2 dimensions ही थे, 2 vectors ही थे, j hat and I hat. Okay, but in the 3D projection we have I hat, j hat and k hat. 3 different vectors are there, and together they do different transformations. Okay, and when we change the values of these vectors, okay, here's the complete matrix for vector 1, vector 2 and vector 3. Here if you can see, vector 1 has 1, 0 and 0. So what vector is there? I hat. Okay, I hat value, if you can see, 1, 0 and 0. Then the another vector which is j hat, 0, 1, 0. Then another vector k hat, 0, 0, 1. So these are active vector spaces on this 3D plane. Okay, and if we want to do some transformations here on the 3D plane, how it looks like, see, if I rotate this, okay, if I rotate this, see, by doing the rotation transformation, the values of I hat, j hat and k hat changed a little bit. Okay, if I show you the transformation, how it has transformed, see, again, this is how the transformation happened. If I zoom in, if I show you the transformation again, look, this is how it transformed. Okay, if I do scale, see how the transformation happened and the vectors are scaled. Okay, if I again click on transformation, see, this is how the vectors are scaled. And if I click on shear, look how it has slightly tilted towards the right. This is the shear transformation. All right, if I say reflect, then it just reflects the entire thing on the opposite side as if the mirror is placed over there. Okay, so it's a mirror reflection. If we want to project this something on a plane, it changes its dimensions and it is projected as if we are projecting the entire thing on a wall. Okay, so see, if I click on project, the entire thing has been squeezed and it is now, if you can see, from any direction, it is projected. When we do projection, okay, when we do projection of any particular vector, then we have lost one dimension. Okay, one dimension is lost in the project transformation. Because see, earlier we have that entire box, we had I hat, j hat and k hat. But if we project something, then we lost one dimension over here. And now it is being projected. If we do squeeze, then how what happens? See, the k hat is squeezed. See. So these are the transformations, and you have to keep in mind whenever we are talking about matrices, whenever we are performing the operations on matrices, this is how the operations are happening on the spaces, 3D space and 2D spaces. There could be any other object on the plane as well. Let's see if there is any car. It's not looking like a car, but yeah, you got the idea, right? Here we have this object, okay? And this is the static position of that object right now. Okay, these are 3 vectors for this object. But if we want to slightly transform this particular object as if it's a 3D object, okay, जो 3D characters होते हैं ना games के अंदर, video games के अंदर, computer games में, so everywhere this linear algebra is working there behind the scenes. Okay, वहाँ जहाँ पर मैट्रिक्स ट्रांसफॉर्मेशंस हो रही है, व्हेन वी टॉक्ड अबाउट इट, राइट, जहाँ पे कंप्यूटर ग्राफिक्स की बात हो रही होती है, वहाँ पे मैट्रिक्स ट्रांसफॉर्मेशंस हो रहे होते हैं. So this is what actually happens in the 3D graphics also. Okay, so if I want to transform it, if I want to rotate this entire thing, if I click on rotate, then look at the values. Okay, I clicked on rotate, the car has been rotated. Now see, the values of the matrix have been changed. So this transformation is happening on these vectors I, j and k, and because of these transformation on the vectors, the entire object is changing its form on the 3D plane. Okay, if I scale it, it has been scaled, car has been scaled. If I click on shear, it is slightly tilted towards the right. If I click on reflect, the entire image is reflected. Okay, if we click on project, see, the entire thing is projected. We lost one vector over here, which was k vector. All right, if I say reset, then again it's back into its original form. It could be any other object as well. Let's say if there's a 3D character, it's not looking like a boy, but yeah, it's a character, it's a 3D character. Okay, and there are I, j and k vectors. But if we rotate this, okay, see, I and k vectors have been rotated slightly, and you can see the matrix transformation. The values inside the matrix have been changed. So whenever we are performing the operations on this matrix, okay, what are the matrix operations? We will be performing it live in another class, but राइट नाउ जस्ट अंडरस्टैंड दैट कोई भी ऑपरेशन अगर मैट्रिक्स पे परफॉर्म होता है तो वो चेंज कर रहा है एंटायर 3D प्लेन को. दैट्स व्हाट द एंटायर क्रक्स ऑफ दिस वीडियो इज. ऑलराइट, if we scale it, see it is being scaled, and the same objects could be looked at on the 2D plane as well. So here's the 2D plane. When we rotate it to the 30-degree, the entire 2D plane is rotated. If we reflect it, see the entire 2D plane is reflected, okay, and you can see the I hat was there. The I hat was in the right side earlier, but when we clicked on reflect, this I hat comes in the negative side, okay. Look, so these are the matrix transformations. I hope you completely understood what are the matrices, okay, what are the vectors, what is the order of a matrix, how does matrices looks like. Here is that. What are the positions of those components, what are rows, what are columns, and yeah, that's pretty much it for this session. And in the upcoming videos, we'll look at all these things: matrix operations, transpose, trace, and different types of matrices. Now, before closing the video, I want to show you a very important thing. Now see, this is a channel on YouTube, okay? एंड ये चैनल है ग्रांट सैंडरसन का. ये बहुत अच्छे मैथमेटिशियन है, राइट? इन्होंने बहुत अच्छा विजुअलाइजेशन करके बताया है लीनियर अलजेब्रा का, राइट? सो ये मैथ्स को ना बहुत विजुअलाइज करके और उस विजुअलाइजेशन वाले फॉर्म के अंदर रिप्रेजेंट करके बताते हैं, विच मेक्स द मैथमेटिक्स वेरी इजी टू अंडरस्टैंड. एंड आई वुड हाईली रिकमेंड यू टू गो थ्रू हिज चैनल. हिज चैनल नेम इज़ 3 Blue 1 Brown, ओके, ये नेम है उस चैनल का. You can go there and there is a specific playlist which is Essence of Linear Algebra, okay, and I want you to go through this particular playlist. I will give the link of this particular playlist in our description, okay, and I want you to go through the entire playlist, okay. But for the very next session, I want you to first complete the first video and the second video and the third video as well, okay, of this particular playlist. So this will really help you a lot, okay. And once you are done with this particular playlist, come back again to our engineering mathematics series where we will continue our journey. And trust me guys, जब आप ये visualizations देख लेंगे, उसके बाद जब अपनी सीरीज को कंप्लीट करेंगे, you will realize that how easy the mathematics is, okay, and how important this visualization was for you. And all the credits of different views, like I showed you different views, physics student का view, CS student का view, okay, वो कॉन्सेप्ट मैंने अपनी स्टडी के टाइम पे यहीं से देखा था, फिजिक्स स्टूडेंट, सी ए स्टूडेंट, ऑलराइट. सो ऑल द क्रेडिट्स गोज टू ग्रैंड सैंडरसन एंड हिज चैनल, 3 Blue 1 Brown. So go there, have a look at this playlist and come back again so that we can continue our journey of the engineering mathematics. So that's it for this particular session, and yeah, see you in the next video. We'll look at the matrix operations. Stay tuned, subscribe to the channel, and get notifications for the next video. Alright, thank you so much. See you in the next video.